In this video, we are going to talk about verifying identities. So we should have already been watching my other videos about how to simplify expressions using these trigonometric identities, but now we're going to verify an identity. In this, where it just asks the question a little bit differently. Instead of saying, hey, simplify this expression, it gives us an equation and it asks us to verify if it's true. So what you typically want to do on this type of problem is we're going to work with the more complicated side of the equation over here, simplify it using our identities, and then see if this ends up being equal to this. If this ends up being equal to this, then we verified it. Then it's a true statement. But if it ends up being something else, then we haven't verified the identity. It might not be an identity at all. So like I said, I'm going to start by working with the more complicated side over here. And so I'm going to start by rewriting everything in terms of sine and cosine. Okay, so my cosecant theta, using my reciprocal identities over here, I'm going to rewrite it as 1 over sine theta. Cosine theta is already cool. And then tan theta is going to be sine theta over cosine theta. And what we're seeing is we're seeing if that equals 1, because at this point we don't really know that that's true. That's what we're trying to verify, right? And so when I look here, I could write that cosine theta over 1 if we want. But here's what I see. Cosine divided by cosine is 1. Sine divided by sine is 1. So what we're really left with, this whole left side of this equation simplifies to 1. So is it true that 1 equals 1? Yes. Therefore, we have verified the identity. We simplified that more complicated side and turned it into the other side. So let's do this example. And this one's going to be a little bit hairier, but we can work with it. So once again, I'm going to start by working with the more complicated side. And once again, I'm going to stick with my guns. I'm going to start by rewriting everything in terms of sine and cosine. So cosecant is 1 over sine. Cosine is cosine. I can put it over 1, and that's my numerator. Then my denominator is tangent, which I can use my quotient identities there, and cotangent, which is cosine over sine. Now, what I'm going to try to do is I really want to treat this denominator right now like it's its own problem. So I have a denominator of cosine here and a denominator of sine here. So I'm going to multiply this by cosine over cosine, and I'm going to multiply this by sine over sine, okay? And then whenever I do that, I'm just going to copy down what I have. My numerator, whenever I simplify it by multiplying straight across, we get cosine over sine in the numerator, but my denominator is going to become this. This right here becomes sine squared theta. This right here becomes cosine squared theta, or x. And if you've been doing these for a minute, you already have little alarms going off in your head. You're like, oh, cosine squared theta plus sine squared theta, that's something. And then your denominator of the denominator is sine x cosine x. Now right here, this is money for us, because if we look back to our Pythagorean identities, that's going to be equal to 1. And so by doing that, we can simplify that down. So actually, we got enough room. Let's come on up here. So I have cosine x over sine x over 1 over sine x cosine x, right? So I just took this and used my Pythagorean identity to substitute in a 1. Now, we have a fraction divided by another fraction. So what I'm going to do to simplify that is I'm going to flip the second and multiply, just like you do when you simplify normal fractions. So I'm going to put sine x cosine x here over 1. So I just took this, oops, that's supposed to be a highlighter. I took that, I wrote it there, and then I put my 1 right there. And then we got some stuff that'll simplify. I have sine x over sine x cancels, and then cosine x times cosine x is cosine squared x. Now, don't forget what we're doing here. We're not simplifying an expression, we're verifying an identity. So let's go back and see what we were initially trying to verify. Oh, there it is. We were trying to show that this equals this. And I found that that's always true. This is just a fancy way of writing cosine squared x. So we've verified the identity because we have proven that this right side of the equation is equal to the left side of the equation. So that's all verifying identities is. It's just like the other problems we've been doing, except they'll just be set in a structure like that, like an equation, and you're going to try to work with one side until it matches the other side. And that's it.